Okay, so we've done the different types of parabolas. Now we're going to start looking at trying to find the equations for these parabolas if I've been given a graph. So I've been given this graph here. Instantly I notice a couple of things, and I've deliberately chosen one where I could use either of my two methods to write the equation, so I can do both of them. Okay, so I'm going to have two different equations, and then I'm going to prove they actually are the same thing, just so you get back into the habit of using the algebra skills you've probably not used since the common assessment task. And then the second part of this video, which may not be in this actual one but might be in the next one coming, is I'm going to use those equations and then I'm going to move my graph. So I'm going to find a new equation. So finding the equations, the first one, I'm going to use the completed the square form. Now this is the one where it's normally y equals something to do with x squared plus a number outside, and the bits that go in there and go there talk about the equation, how it's moved as a transformation across and up and down. Okay, now the first thing I notice is my graph is an n shape, so it's not an x squared, it's a minus x squared, so I'm going to chuck that in first. The next thing I notice, it's moved one space to the right. Now if we move to the right, that's a minus 1 coming across, and remember I'm looking at the vertex point to help me work out what the movement has been. The last point I've got to work out is that it's moved up 4. So therefore I'm going to add 4. Now the last thing I better check is that as I go across 1 down 1, across 1 down 3, across 1 down 5, that works. So there's no other scalars in there. Right, so that's the completing the squared form. The second method I could use to do this first part is using the factorised form. Now the factorised form is when I look at my roots, and my roots are at minus 1 and 3. So therefore when I write the equation of that, I swap the signs, so I get x plus 1 and x minus 3. Again, this is a negative quadratic, so I need to give myself a minus sign out front, and then I need to check that the y-intercept is actually right. So plus 1 times minus 3 is minus 3, times a minus makes it a plus, my y-intercept's y. So there you go. Now let me just show you that if I go from here and use FOIL, I get x squared minus 3x plus x minus 3, but that's with the minus outside, so that is minus x squared plus 2x plus 3. Minus 3 plus 1 is minus 2, but the minus makes it a plus, and minus makes that a plus. That's my quadratic formula, and if I look here, x minus 1 squared is x squared minus 2x plus 1 plus 4, but remember this bit has a minus outside, so that is minus x squared plus 2x minus 1 plus 4, which is minus x squared plus 2x plus 3, and those two equations are the same. Sorry it's not as neat and tidy as it could be, but there you go.